Loan origination fees are intended to cover expenses incurred by the lender for processing and underwriting loan applications, preparation of loan documentation and amortization schedules, obtaining credit reports, and any other expenses that the lender believes should be recovered from the borrower. Loan discount fees or points adjust the yield on a mortgage loan. Buying down the interest rate is the practice of charging borrowers loan discount points instead of raising the interest rate. So let's work through an example. Let's go back to our $60,000 6% 30-year loan. But let's assume that it includes fees equal to 3% of the loan. In order to calculate the effective interest rate on the loan after factoring in these fees, our N will still be 360, but now our present value is going to change. Instead of 60,000, we're actually going to subtract off the fees. So it's going to be 60,000 minus 3% of 60,000, which is 1,800. So our present value is 60,000 minus 1,800, or 58,200. We'll still use that payment of $359.73. We're going to enter it as a negative number because it's a negative cash flow, but that was the payment that we calculated for our fully amortizing loan. And the future value will be 0. And now we're going to solve for the interest rate. We will get 0.5239 as the monthly rate, and if we multiply that by 12, we'll get an effective interest rate of 6.29%. Now, what if we have the 3% in fees, but the borrower prepays after 5 years? Then what's the effective interest rate? Well, our first step will be to solve for the remaining balance, just like we've done before. So the remaining balance after 5 years means that there's 25 years left on this 30-year loan. So our N will be 25 times 12 is equal to 300. The interest rate is still going to be 6 divided by 12, or 0.5. And the payment is still going to be negative $359.73. Future value will be 0, and we'll solve for the present value. We'll get $55,832.57. Now, step 2 is solving for the interest rate. So we want to know the effective interest rate on the loan when it's prepaid after 5 years. So N will be the 5 years, or 5 times 12, which is equal to 60. The present value is the same as the present value when we calculated the effective interest rate when it was expected to be paid over 30 years. So that means our present value is 60,000 minus the 1,800 in fees, or $58,200. The payment is still negative $359.73, and the future value is what we solved for as the remaining balance after 5 years, or a negative $55,832.57. Now we can solve for the monthly interest rate, and we'll get 0.5609. If we multiply that by 12, we'll get the nominal effective interest rate, which will be 6.73%. Now let's assume that a lender wishes to earn a 7% yield on a 30-year 80% mortgage, and they expect on these mortgages they're typically going to get repaid after 10 years. So they want to charge a fee along with a 6% contract rate so that effectively they'll be earning a 7% yield. Well, our first step is going to be to solve for the payment per dollar borrowed, because again, we're looking at this from the lender's perspective, so we don't have a specific loan that we're considering. They're just basically trying to set their policy based on their desire to earn a 7% yield. So, solving for the payment per dollar borrowed, we're going to assume 30-year loans, so N will be 30 times 12 or 360. We said that the contract rate was still going to be 6%, so I is going to be 6 divided by 12 or 0.5. And remember, we're just solving for the payment per dollar borrowed, so present value is going to be negative $1. And the future value will be 0 because we're going to calculate this for a fully amortizing loan. So if we solve for the payment, we'll get 0.005996. Now then step 2 is going to be to solve for the loan balance after 10 years. And again, this is on this theoretical $1 loan. So N will be 10 times 12 or 120. The interest rate will be 6 divided by 12 or 0.5%. And the payment will be that 0.005996. The present value will be negative $1. And now I could do this a little differently than we've done in the past. And instead of solving for the present value of the remaining payments, I'm going to solve for the future value of the payments that were actually made. And so I'm going to get a future value of 0.836857. Then step 3 is to solve for the present value at 7%. N is equal to 10 times 12 or 120. The interest rate is 7 divided by 12 or 0.5833. The payment is still 0.005996. And the future value is what we solve for, the 0.836857. We solve for the present value and we'll get 0.932931. So that means that in order to achieve a 7% yield, the lender is going to have to disperse 0.9329 or a little more than 93 cents for every dollar borrowed. So that results in a 6.7% origination fee because they're only going to disperse 93.3% of every dollar that's borrowed to get that 7% yield. So that means that their fee is 100 minus 93.3, which is what they're dispersing, or 6.7%. Now, what if the lender agrees to finance the loan fees? So in that last example where we had 3% in loan fees, and that means instead of reducing the loan by $1,800, we would actually add $1,800 to the loan amount. And so what's going to happen is our payments are going to increase. So N is still 30 times 12 or 360. I is still 6 divided by 12 or 0.5. But now our present value is going to be $60,000 plus $1,800 or $61,800. Future value is 0. And then we solve for payment and we get negative $370.52.